Start.
Hi, this is Ritika Rao. I'm a part of Group 63, and we're presenting our project on customer profiling. Next slide. Uh, the topics that we'll cover under this presentation are the introduction of what customer profiling is, data overview, the exploratory data analysis that we conducted, data pre-processing, and then we'll move on to all the modeling steps that we took for clustering, classification, and regression. We'll then move on to selection and evaluation of models and the conclusions that we drew. Uh, As a part of this project, customer profiling has three main segments: customer segmentation, customer analysis, and market basket analysis. Customer segmentation uses RFM analysis technique, which is essentially used for clustering customers into high value, low value, and mid value customers. This is really the heart of the project. The output from this customer segmentation is then used to predict churn of a customer and customer lifetime value. We've also done market basket analysis, which essentially uses association rule mining to identify products that are often bought together. Next slide. Customer lifetime value is basically the net profit that a customer is bound to provide over their entire relationship with us. And customer churn is basically identification of customers that are about to stop doing business with us. These aspects can be then used for designing marketing strategies, retention strategies, and other sales techniques. The data that we've picked is from Kaggle. It's a retail sales data. It has three tables: transaction table, customer table, which has a demographic information, and product category info basically maps the product category code numbers to the product category names. Okay. Exploratory data analysis. Under this, we first drew a correlation heat map of all the columns that we had available. It is very clear that tax rate and total amount are highly correlated. Also, quantity and total amount are highly correlated. This is because total amount is calculated as quantity into rate plus tax. So what we ended up doing was we dropped the tax column because it was like literally one correlation, and we also dropped the rate column as it was also having really high correlation. Under univariate analysis, we were trying to see if there is any correlation between customer demographics and their spending patterns, but as it is evident from these graphs, there is not much to draw here. Next. We go ahead and check all the popular categories. As we can see, books, electronics, and home and kitchen are popular product categories, and the fashion categories aren't really popular here. Customer spending based on cities again says that there is no way we can use cities to then determine customer behavior. Product category, sales trend by gender and store type. This basically gives us one key important information, which is e-shop is the most used store type, and males dominate sales in most of the categories except footwear and bags. While this time series data for weekly sales trend doesn't really give us any seasonality, we can see that there are high peaks on most celebratory vacations, which means that sales during these period would work well. Under market basket analysis, essentially what we tried to do was understand the customer behavior and their purchasing patterns. So we tried to see which products are often bought together with which other product categories. And we used association rule mining for these. These relationships can be useful in general when it comes to product recommendations. Next. So as per our analysis, as you can see from the table, that books and electronics are usually bought together with other items that customers are buying from the website. We can use this information to then suggest books and electronics whenever any customer is buying. Next. Under data pre-processing, the main issue that we found out was there was a couple of transactions where multiple refund records were also present for like just one single transaction. We cleaned these out by removing all these transactions. These are some minor data pre-processing code snippets. Under feature selection, we try to do like three different types of models, essentially lasso, tree-based, and boosting models to find the feature order of importance. What we found, next slide. What we found was, according to all three, there was a different order of importance for each of them. So we tried to remove the transaction ID and customer ID and try it again, but the outcome was still non-conclusive. So we just went ahead with all of our features. Under modeling objectives, we have customer segmentation, which uses clustering, customer churn, which uses classification, and customer lifetime value, which uses regression. Next. So under clustering, we've used the k-means, hierarchical clustering, and dbScan method. K-means is basically a similarity-based method. Hierarchical clustering is a tree-like structure of clusters, and dbScan uses density-based algorithm. Next slide. To perform this clustering, we went ahead with the RFM analysis for customer segmentation, where R stands for recency, which is how recently a customer has bought from us. F stands for frequency, which is how often they make purchases from us. And M stands for monetary value, which refers to how much they have spent so far with us. We then use these three derived features to cluster this customers into high, mid, and low value. Next. We then use the RFM information to predict the customer lifetime value. We used regression algorithm for the same. We've used linear regression, tree related algorithm, distance based algorithms, and many other, as you'll see in future slides. And churn prediction is a classification problem for which we use logistic regression, random forest, and XGBoost. We specifically use the recency feature for this task, as we did not have any other interactions related information, or the demographics wasn't really useful in this case. Debanjan will go ahead.
Thank you, Ritika. So we implemented a lot of different types of model, including regression, classification, clustering, and we use different types of metrics in order to evaluate those models. So now we will look at the various model selection and evaluation techniques. So first, coming to clustering, we had three different types of models like k-means, plus, agglomerative, and dbScan. So we can see that dbScan, we couldn't identify the clusters uniquely because the clusters were quite overlapping. And then we had k-means, where we had good cluster separation. The next slide, we can see that we have used Dunn index, Lovett score in order to find the optimal clusters. And here, Dunn index shows that the optimal cluster is 11, but from our domain knowledge, we knew that the cluster number should be 3 or 4, which is as shown by the Dunn index for hierarchical model. Now here we see how we can separate the clusters based on recency using k-means and agglomerative clustering, and we can see that k-means is able to uniquely separate the clusters, whereas agglomerative is not. So clearly, we chose k-means for this task. Coming to classification, there was a dataset imbalance problem, class imbalance, because the number of churners and non-churners were not the same. So we used both oversampling and undersampling. For oversampling, we used mode and normal undersampling. And we used three main algorithms, logistic regression, random forest, and XGBoost. And we found that XGBoost classifier was the perfect model for this case. Coming to the final task of customer lifetime value prediction. So this is basically a regression model, and we trained a lot of regression model like stochastic gradient descent, where after tuning the hyperparameters, we got a good RMSE. Then we used distance-based algorithms like KNN, and we used various different distance metrics, as you can see on the slides. Then we also used lasso and ridge regression, and we found that the regularization parameter did not have any effect on the um, whole algorithm. We also used light GBM and various other algorithms. Here you can see a list of all the regression models which we tried out, and we evaluated them using RMSE, median absolute score, adjusted R2, Spearman's R, and many other metrics. And out of all this, we found that the linear regression was the best model for our task. And here is the actual versus predicted for linear regression. As you can see that our model generalized pretty well. It did not overfit the data. As you can see that the spikes of actual data in those places, the predicted model has generalized well. Coming down to the final task, which is calculating the future lifetime value. So we calculated the future lifetime value of 365 days in advance. And here we can see the distribution of the future lifetime value, where most of the customers are between 5,000 to 10,000. And here are the top 10 customers. As you can see that all the top 10 have a lifetime value of over 23,000. So that's about the whole project. We did market basket analysis. Then we used clustering. From clustering, we used churn prediction and customer lifetime value and created the whole customer profile. Thank you.